Welcome to Brain Vision.
For this problem on the topic of curvilinear motion of particles, we are told the velocity of the block B as shown in the diagram, as well as its acceleration. And at that instant, we want to determine the velocity of block A as well as the acceleration of block A. So if we look at the diagram and the given variables, we are given the velocity of block B to be 2 feet per second to the right, and the acceleration of block B to be minus 3 feet per second squared. So that acceleration is to the left. Now, if we write down the length of the cable L, the length of the cable L is equal to YA plus 2XB plus some constants, so we'll call it C. Now, if we differentiate the length equation, we can find the velocities. So if we differentiate once, we get 0 is equal to VA, which is dy dt, plus 2VB, which is dx dt, and we'll call this equation 1. So 0 is equal to VA plus 2VB. And if we differentiate this equation, we can get the acceleration. So we differentiate with respect to time again, and we get the acceleration of AA plus 2 times the acceleration of B to AB is equal to 0. So we have equation 2. Now, if we rearrange equation 1, so from 1, we can see that the speed of A is equal to minus 2 times the speed of B. So they move in opposite directions. So VA, we can clearly see, is minus 2 times 2, which is minus 4 feet per second. So the velocity of A is 4 feet per second upward. From our diagram, we can see we've taken the downward direction as positive and to the right as positive. So the velocity of block A is 4 feet per second upward. Now, if we rearrange equation 2, we get the acceleration of A to be minus 2 times the acceleration of B. And since we know the acceleration of B, we can calculate this to be minus 2 times minus 3, which gives us the acceleration of A to be 6 feet per square second, and this is positive, so this is downward.